Hi, welcome to my lesson on slope and what it means and how to calculate it. So let's get started. The first one here is I have a graph uh, and XY plane, and we're going to put a couple points in here. The first one is going to be, let's say on my graph, I have the point, what's that? That's 1, 1. So 1, 1. And going to the point, let's say right here. And that point is, let's say, right here. 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5. And so the question is, find the slope from this. So the slope is the, also known as the rate of change. So when I say this, we can also say rate of change. So slope, rate of change, it's all the same thing. Change in y, change in x, rise and run. These are all different ways of describing slope of a line. And I'm going to draw this line like this. So what I'm asking, what's the slope is, I'm asking, well, how steep is the line on the graph? And that steepness is calculated as this. That triangle is called delta. Delta y divided by delta x, or the change in y divided by the change in x. And that is known as rise over run, because when you rise, you're going up and down, the change in y, and the y value is the vertical axis, and the run is the change in the x, or the horizontal axis. And this right here is called y sub 2 minus y sub 1. And we're just taking two y values and subtracting them versus two x values and subtracting those. So I'm going to calculate the slope on the line, and I'm going to do it without the graph. So I'm going to do it two different ways to show that you get the same answer. Because sometimes you're given the graph and sometimes you're just given the points. So the rise. First off, I'll take the left dot going to the right dot. And I like to do it like I read a book, from left to right. Now, this slope is going upwards, which means it's going to be a positive slope. The rise is going to be from here to here, going straight up. So I count, that's 0 right now. I haven't moved at all. And going up 1, 2, 3, 4. So the rise is 4. I'll put a big 4 here. The rise is 4. And the run is as I go up. Now the run is going to be how far I go straight to the other dot horizontally now. So that's to the right, 1, 2. The run is 2. So the rise is 4 and the run is 2. And so the slope, right here, slope is the rise, 4, divided by the run, 2. And I could simplify that to 2 over 1. And 2 divided by 1 is just 2. So the slope is said to be 2. Now, when I see the up 4 and over 2, that means I went up 4 and over 2. But if these are fractions, I can also go up 2 and over 1, and I should still be on the line. And we can test that. As we have here, I go up 2, 1, 2, and over 1. I'm exactly on the line. And I can repeat that slope. Go up 2 again and over 1 using this little slope right here, up 2 and over 1, up 2 over 1, up 2 over 1. I'm still on the line. So that's a pretty nifty thing here. Now, if I were given just the points here, this is said to be, my points are 1, 1, and the other one is 3, 5. So this is the x value, and this is the y value of the point, and this is the x value and the y value of the second point. Now, since I'm calling this the first point, I'm going to call this x sub 1 and y sub 1. So x sub 1, y sub 1, and this is the second point, so this will be x sub 2, y sub 2. See? So now we can see that we can plug these numbers into our formula right there. y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what I should get is 2 when I'm done. So we have, let's see, y sub 2, that's a horrible equal sign. So y sub 2 minus y sub 1. So y sub 2 is 5 and y sub 1 is 1. So 5 minus 1, 5 minus 1. X sub 2 is 3 and x sub 1 is 1. So it'd be 3 minus 1 in the denominator. Now I have 5 minus 1 is 4 and 3 minus 1 is 2 and 4 divided by 2 is the same thing. And here, right here, I now have this same thing right there. See, those are the same. And that equals 2 over 1, which is 2. See? And what is happening here is we're counting from 1 to 5. What is that rise? I go from 1 to 5. Well, that's a rise of 4. See, that's what's happening in the graph right here. And the run from 1 to 3, that's, you're going, well, 3 minus 1. That difference here is 2. So that's why this works out. Okay, let's go to another example. And instead of going upwards, let's go downwards. And we'll take this point here and this point here. So this point right over here, let's see, what is that? That is 1, 2, 3, 1, 2, 3, 4, 5. So it's -3, 5. And the other point is 1, 2. 1, 2. So graphically, we can look at this and see the slope right there is, well, as I go from the left dot to the right dot, I'm going how far down? 1, 2, 3. I'm going down 3. I'm going down 3. I'm going to call that -3. See here, I went up 4, so I got a positive 4. So now that's going down 3, so that's -3. And then the run, well, the run's always going to be positive. So the run this way, I'm going straight 1, 2, 3, 4. So I'm going to the right 4. So the slope is the rise, which was -3, over the run, which was 4. So the slope is -3/4. Okay, so that's if I am given the graph. Now, let's say I'm only given the points here, and I'm going to find the slope, which is the change in y over the change in x, rise over run, which I was just using right here. And we're going to use this, let's see, I'm going to make these points a little bit bigger. -3, 5, -3, 5, and 1, 2. And this is the x value and the y value, the x value and the y value. This will be my point 1, and this will be my point 2. And so on top, I have to subtract the y values. So y sub 2 is 2, y sub 1 is 5, so it'd be 2 minus 5. 2 minus 5. And the x values will be x sub 2 minus x sub 1, 1 minus -3. I'll check that out. 1 minus, and then what is the, this is 1 minus, what is that? That's -3. So 1 minus -3. And 2 minus 5 is -3. And 1 minus -3, well, if you remember positive peanut on that, that's actually 4. And see, now we get the same answer here as we got here. And that's what you got to know about graphing and finding slope from graph and from points. And I hope this was helpful.